Yeah, okay, we see the
Okay.
presentation, we see your
Right.
pulpit. Yep.
So, well, as you mentioned, Thomas, we'll have a quick look at Apache Hop today. Couple of the topics that we'll cover is a quick overview of Hop, why Hop, and then an overview of the platform. What are the guiding principles, some of the key features, roadmap, community, quick word about enterprise support, and then, well, I bet it's time to do a bit of a dive in and have a look at what Hop really is and do a quick demo. So first of all, what is Apache Hop? Hop is a recursive acronym for Hop Orchestration Platform. Well, at the introduction, you mentioned, or you asked if you pronounced that correctly. One of the reasons we chose Hop as a name is because we wanted a project name that is short and that is close to impossible to mispronounce or misspell. So that's, yeah, that's one of the reasons we chose Hop as or that Hop was chosen as a project name. Hop is an orchestration platform, so we do process data. Pipelines and workflows are two of the key concepts that we use to process that data. We'll go into that in a bit more detail later on. Metadata is crucial in everything that Hop does. Hop is entirely metadata driven, and we use metadata to define pipelines, workflows, to do the data handling, to do all of the management, and metadata is really one of the key parts of what Hop is and does. Another important aspect is insights. In managing the data, there's a lot of, well, information on the site that is really important. It's important to know what is going on. So what the execution data is, what the lineage is of your data, managing logs is important, and all of those insights are gathered within Hop and are ready for consumption later on and for monitoring and logging. So to get a really good view of what is happening to the data that you're processing. Configurations are another important aspect. We integrate with, well, actually with all the previous and next topics in the DataOps meetup. Kafka, MongoDB, Elastic are all, we all have integrations for those. So managing those configurations is another important aspect. Bit of background about Apache Hop. Hop is entirely community-led, so there's no well, corporation, no large company that sort of owns Hop. And the background that we have in Hop is we started in late 2019, so a year and a half ago, as a fork of the Kettle project that you may also know as Pentaho Data Integration. And well, we started as a fork, but the idea was to keep the good things of Kettle, of PDI, and do another couple of things radically different. So we used the 8.2 code base of Kettle with WebSpoon, with a couple of patches and a number of plugins, and started building a platform of our own. So we have the new development that goes into Hop, but we also inherit the 20 years of development that have gone into Kettle. So we have, even though we're a young platform, we have a lot of background, a lot of functionality that is available. One of the things that we did from the very beginning was create a new user interface. The Spoon, the UI that you used to build workflows and pipelines in PDI and Kettle was a bit or was outdated, and we replaced that with an entirely new GUI that is taking more and more, or starting more and more to look like a real IDE development environment for data orchestration, data engineering. We rewrote the metadata backend. The tool set was simplified. We now have a UI component, a server component, a command line component, a configuration component, and all of those are in sync and are well, pretty easy to use, are pretty consistent, so that makes it easier to recognize things across the different tools. And of course, we refactored, renamed, trimmed down. We did a lot of cleanup before we started rebuilding the Hop platform. I think we went down from about 2 gigabytes to a little over 350 megabytes now, so with more functionality. So the trimming down has been significant. And we added a number of new plugins, project management, testing, Apache Beam. We'll look into that later, debugging. We're now working on a couple of new plugins, Git integration, for example. So there's a constant flow of new functionality coming. The incubator. We are an incubating project at the Apache Software Foundation. The incubation process basically means that we have to adapt to the Apache Software Foundation's way of working. We have to, well, work according to their standards, make sure that licensing is according to the Apache license, that all the dependencies that we use are correct, are okay, are APL compatible. So that's a big part of what the incubation process is about. And we're making a lot of progress there. More on that in a minute. Our source is available, of course, in the Apache organization, but at Incubator Hop, we have continuous builds on the Apache Jenkins server. The latest version that we're continuously building is 0.70, and we're actually working pretty hard to prepare that release at the moment. The last release that we had was 0.60, but if you take into account what I just mentioned, that we have this history of 20 years of development, that low version number, 0.60, 0.70, may be giving you the wrong impression that this is an immature, young project. We are a young project, but we have a lot of background. And well, with the continuous builds, continuous integration testing that we do, we have a pretty stable platform. The integration testing that we do now have uncovered some bugs that must have been in the platform for about a decade. So every bug in that, in that scene that we find makes the product more stable, more mature. And very important is our community. We are community driven, and we have a pretty active and growing community. We have, I think, about 150 people who are active on the chat now, a couple of hundreds of followers on LinkedIn, on Twitter, and that continues to grow consistently. And of course, the website, Twitter, LinkedIn contain the latest updates of where we're going as a platform, as a project. Why Apache Hop? In the data landscape that we have these days, platforms come, platforms go, and the entire landscape is really diverse, changes very quickly, and that makes it hard to manage. So we wanted Hop to be a platform that handles that complexity and takes a lot of the or makes that manageable for users, for data engineers, and that allows us to adopt new technologies quickly, to innovate quickly ourselves as well. Hop as an Apache project is important to us because it allows us to build a platform independent of a single large corporation. There are some companies, organizations that sponsor the development of Hop, but there is no single organization that controls the roadmap, controls any aspect of Hop. So that independence is really important. And of course, Hop is built by and for data orchestration professionals. The use cases, the bug tickets, the feature requests that we have all come from the field. People who use Hop to solve their problems, to build projects, are what drives us. That's what we do ourselves, and that is what the community that we have in Hop is all about. Couple of the guiding principles. Hop intends to be easy to set up, to build, to maintain, to deploy. We'll get into more detail on that in a minute, but starting Hop is as easy as downloading, unzipping, and running Hop GUI. While building, maintaining, deploying is an area where we are continuously spending a lot of effort to make things more consistent, easier, and more intuitive to use. We have, for example, the concept of project and environments, where you specify a project with a number of environments: development, UAT, production, and the configuration for those environments within that project is picked up automatically. Fast, we went down. I mentioned the download size that went down from about 2 gigabytes to 350, 380 megabytes. We have a similar situation in startup time. We went down from a couple of minutes in some cases to a couple of seconds now, to 3, 4 seconds. We remove the splash screen because it doesn't make any sense to have a splash screen for an application that is available in 1 or 2 seconds. We have support for Spark, Flink, and Google Dataflow over Apache Beam. That allows us to build and run our pipelines on platforms that are built for performance. And transparency is another important one. It has to be clear what the status of a pipeline of your data is before, during, and after execution. Same for predictable. A transform in a pipeline always have to return the same results, and that's where unit and integration testing of the pipelines come. Innovative. We want to stay ahead of the curve, want to adopt new technologies, and best practices are another important aspect. We're now building version control, Git integration. We had a lot of focus on testing, CI/CD, and best practices within the project lifecycle, to make sure that the results of what people build with Hop are as good as it gets. So, a couple of the key features. Well, we're APL licensed, of course. Hop is metadata driven and is an engine, so we are not a code generator. We have Hop is an engine that interprets your metadata and executes your data based on that metadata. A modular, pluggable architecture. In the refactoring and code cleanup that I mentioned at the very beginning, we focused on creating a kernel plus plugins architecture. And the scale back to -30 is where you keep basically only Hop engine, so the kernel with a minimal number of plugins, and everything still works. And all of the additional functionality over those 13 megabytes are added through plugins. I think we have about 250 plugins at this point, and the number grows each month. Fast startup, minimal overhead, and Apache Beam is another important one as a plugin again. Apache Beam is a project that adds a unified layer for Apache Spark, Apache Flink, and Google Dataflow. So our pipelines can run on Hop's local engine, Hop's local runtime, or on the Spark, Flink, and Dataflow runtimes basically without changing any of the code. Documentation is another important one. We wanted to have a platform, and the community is working really hard to build that documentation, where every aspect of the platform is documented. We consider documentation to be code as well, to be part of our software, and bugs, feature requests in the documentation are treated just like any other piece of code. So we keep our documentation in Git as ASCII doc and generate PDF and HTML documentation based on that code base. Ease of use is an important one as well. We want to keep things as transparent as possible, make sure that the user interface is as transparent, as intuitive as possible, and that the functionality that is available in the UI is available in the other tools as well. So in the command line, in command line and other tools. And integration testing, what I mentioned earlier is that we have a couple of unit integration tests that are part of our daily build, so that that increases the stability and the maturity of the platform. Couple of key features of the GUI. The GUI, just like everything else in the platform, is pluggable as well. That helps us to develop very, very quickly. New plugins can be added in a matter of hours. We have a couple of things that we focused on. The scalability was an important one. High DPI displays are everywhere these days, and the UI needed to be able to handle that. So we can now zoom in. There's in the middle of the screenshot, there's a zoom button. We can zoom in to zoom in, zoom out, and the user interface scales accordingly. All of the entire graph that you see in the screenshot is an SVG, scalable vector graphic, so it scales pretty nicely. We have a couple of perspectives to switch between contexts for metadata management, search, and of course development. The UI was written with a couple of use cases in mind. So we have a desktop application. The web client is getting really close now, and because we wanted to keep the desktop application and the web experience as close to each other as possible, as unified as possible, we focused on having as many single-click actions as possible. And that has the added advantage that doing only single clicks instead of double clicks and right clicks, etc., makes it really fast to develop. And we have full support for the 4 platforms: Windows, OS X. A lot of our developers use Linux, so that works really well as well. And web is becoming an important one. We are in the process of unifying the desktop and web code bases, getting really close there as well. And we'll, in a couple of weeks, I guess, we'll have one single code base that will work for the desktop and the web. Yep. Is there a question? No, sorry.
No, it's just one of the participants on mute. Accidentally, I would say.
Okay. And the recent addition is a dark mode. We needed to have a dark mode, and that became very popular overnight. So we now have fully functional dark modes on Linux and OS X. On Windows, it's a bit harder, but that seems to be a general problem with dark mode on Windows. Okay. As I mentioned before, all of the GUI options have a command line equivalent. Well, all of the configurations are managed through JSON files. Project lifecycles, I'll show that in more detail in the UI in a minute. One of the latest additions a couple of weeks ago, maybe a month or so ago, is that we now have configuration metadata inheritance from all the projects. So you can define one root project and then a couple of child projects where the lower level, the child projects, inherit the configuration from the higher, the projects in a higher level. We have a standard Docker container that is part of the build, and that is getting really mature now. Stateless server and version control friendly setup. The stateless server is nice because that allows us to run on the local, on your local machine, on the local Hop engine, or on a remote engine from the same UI. The user experience is exactly the same, but you can design a pipeline or a workflow on your laptop and run that pipeline remotely on a server that has a lot more resources than what you locally have. Quick words about our roadmap. Like I said, we're now in the process of preparing our 0.70 release. 0.60 was our last release, was our first release as an incubating Apache project. Version 0.70 will have binaries, so will be the first release where we have downloadable items that are not nightly builds. Then we'll do a 0.80 and move to a 1.0. And I think it's fair to say that we're, in terms of functionality, we're at a point where we're ready to run in production. We have a number of projects that are used in production, and that's, I mean, that is okay. There is no reason not to run Hop in production, regardless of the version number. The version numbers are more oriented towards our incubation process and the functionality that we want to include, rather than stability or maturity of the platform. We are working on a project file explorer. Actually, that is going along pretty nicely. We can now explore files in the Hop GUI. We are working on full GUI support for Git, so you'll have commit, push, pull from within the Hop GUI. Pluggable field expressions is another one where instead of using a hard-coded field or a variable as an input parameter, you will also be able to create expressions, and that will open a lot of possibilities to integrate with other data integration platforms. Java 11 is another important one. We're still at Java 8 mainly because we have a dependency on the Apache Beam plugin, and as soon as Beam moves to Java 11, we'll follow. We have done some checks, and the switch to Java 11 shouldn't be huge. We'll work on more cloud integration. And we'll increase the number of samples and integration tests that we have. We have a number of, well, quite a number of integration tests by now. A number of samples is growing, and we want to be feature complete there before we go to 1.0. Last but not least, our community. Well, the ASF, the Apache Software Foundation, is all about community. Community and the release process basically are more important than the software itself, as far as the ASF is concerned. So, well, we truly believe that great communities deliver great software. And during the incubation, well, we were asked to grow the community and release software the Apache way. Both are well in progress, I would say. Our community, well, grows every month, and we start to see more and more traction around Hop. There are more articles on Medium, mentions on LinkedIn, on Twitter, people who are migrating their old Pentaho projects to Hop right now. So a lot of traction that is building. And well, as mentioned before, there's no single company driving the software forward. What we actually hope is that we'll have more and more companies getting involved in the development of Hop. And anyone is welcome. We are very open to people who have questions, who have ideas, who want to contribute to Hop. I think the most active area is our chat, where we encourage people to mention the problems that they have, discuss feature requests, and well, no bug is too small or too big to fix. I think we're doing a pretty good job there. And the same for improvement suggestions. And well, very quickly, enterprise support. Open source is free to download, free to use, but in the pure open source model, you're on your own. So we have a company that is well, starting up right now that helps you with support, training, certification, custom development, you name it, everything related to Hop. That's it in a nutshell. Feel free to follow us on Twitter, on LinkedIn, and above all, join the discussion on our chat project hop.org. Any questions so far? Okay.
I don't see any, so I think we can move on.
Okay. let me know if you don't see my Hop GUI at the moment.
We can see.
Okay, perfect. Well, I mentioned the Hop GUI a couple of times during the slides. This is what it looks like. So we have a couple of perspectives on the left-hand side. There's, well, Plugin Explorer is pretty technical. There's a search perspective where you can search for any metadata item in your setup. We have the metadata perspective where all of the metadata items are, well, can be managed. So we have database connections, runtime run configurations for pipelines and workflows, etc. And the new file explorer that I mentioned is where we are building Git support as well. So like in most IDEs, IntelliJ, for example, we are working on a system where a changed file will get a color coding. So, well, committed files are green, changed files are blue, things like that. And the perspective where you'll spend most of your time in is the data orchestration perspective, where you'll design, run, test your pipelines and workflows. So the way it works is we have the plus button here where you create an item. In this case, I'll create a pipeline. The difference between a pipeline and a workflow, the two major file types that we have, is that a pipeline is where your data processing really happens. So in a pipeline, you read data from one or more sources, do a number of operations, do a cleanup, enrich your data, join data from a variety of sources, and finally write your data to a number of target one or a number of target platforms. And within the pipeline that I opened, if you single click on the canvas, there's a pop-up where we have all of the transforms that are available. So for example, if I use a generates rows, this just generates a dummy, or not a dummy, generates a number of sample rows. There's a fake data generator. Okay. And each of these transforms that you add to a pipeline has a number of properties. So I'll edit, and this fake data has a type. So for example, I'll use a character. And on each of these transforms that I added to my pipeline, I can do a quick preview. Well, that popped on my other screen. I'll do that again. So here I can just specify defaults are usually fine. I'll do a preview of the first 1000 records, do a quick launch, and I get the 10 rows that I generated that are now populated with a character from Star Trek. And what you do next is chain these, chain the transforms in your pipeline together. So you can now add a select values, I'll add another one, add a sequence. So a sequence is a counter. I'll name this counter. I'll add the counter to my pipeline in select values, which is another very common transform that we have, where you can do some basic operations on the structure of your pipeline stream. So you can make a selection of the fields that we have. This is a very simple example, but in a lot of real life use cases, you would have tens of fields, and it makes sense. Or sometimes you need to reorder, rename, whatever, remove in some cases. In the metadata tab, you can change data types. So for example, if you read in a CSV file that has date fields that need some formatting or some cleanup, you can read them in as a string, do a couple of operations, and then change the data type to a date in the select values. So in this case, I just reordered reordered the fields, sorry, and I'll do a preview again. Okay, nothing really exceptional here. Then I'll save my pipeline. And the pipeline is now saved within the concept of my project. So I have a list of projects here, and each project has a number of configuration options. We have a JSON file where the project configuration is stored. There is a metadata folder, a data set for unit testing. You can specify a number of project variables here. And with each project, you can specify an environment. I haven't used an environment in this case, but you could, well, in real life projects, you would have development, UAT, and production here. And the configuration for your file paths, database connections, etc., would be picked up from the environment variables that we set here. And then if I run this pipeline, we have a run configuration drop-down box here, where I can specify a local configuration. We also have Dataflow, Flink, Spark. I'll get to that in a minute. And well, of course, these are only 10 rows, so it runs really quick. We have in the bottom of the screen, we have an overview of what happened here. So all of them are finished. We generated 10 rows, moved them to that fake data generator, added a counter, and reordered. And we have a quick overview here of the lines that have been input, output, read, written, and updated. And this is, well, input and read is the I/O, physical I/O that you do from disk, so from a file, from a database. And written output is between the different transforms in the pipeline. What I mentioned is the zoom, so you can scale 800 was a bit too optimistic. So if you zoom in to a large level, you can have, well, zoom in or zoom out on your pipeline graph. and workflows are pretty similar. In a workflow, what you'll typically do is chain the results of, or chain the execution of pipelines and some other orchestration tasks together. So if we look at a bit more, well, this is still a demo, but a bit more real life data. We have a dummy data set of 1 million customer records, where we get today's date. So there is a get system info transform where I now use the or picked up the system date, but there is a large list of options that you can specify there or choose from. And that gives you access to a number of data items, some information about your Java virtual machine. We have a calculator similar to the get system info. You have a list of operations that you can do here. So do basic calculations, data operations, do file checksums. There is encoding, decoding. Actually there's quite a lot that you can do in the calculator step. And I use this step here to create the age, then use a number range to group people once we know their age into age groups between young, middle-aged, or older, and then build a file name and write that file name out. And well, this is an example of a workflow where we have a start. Difference between a pipeline and a workflow is that a pipeline runs everything in parallel. So these the 4 transforms in this pipeline all run in parallel. The data is processed at the same time. In a workflow, the process is sequential. So we'll use the start workflow here, then process this pipeline once that pipeline is done, and we'll add another one. For example, well, I'll add 1 or 2 additional pipelines here. And then finally a success. And the difference in the hops between what we saw in pipelines and workflows is that the hop in a workflow is conditional. So if I click on the icon here, it is either unconditional when result is true or when the result is false. So basically this determines whether that the second pipeline here will be executed if input process output has executed successfully, or we want to execute this pipeline when the previous one failed, or unconditionally. So doesn't matter whether the previous action pipeline or other action failed, will always execute this pipeline. And another thing to look at is the different runtimes that I mentioned in the presentation. So in this case, we have a beam input and output file definition. We'll use this. We'll use this pipeline to run on DataFlow, so Google DataFlow, and this will package the pipeline, the code that we need, send it off to DataFlow, and there we'll be able to follow up what is going on. So this is my data flow console. There is a new input process output job that just started running. And as you can see here, the different nodes that Dataflow creates are all have the same name as what we created in our pipeline, and that is, well, makes it pretty easy to follow up what is going on, what beam has been given by our Hop pipeline. This takes a while to run, so we'll get back to that in a second. While that is running, let's have a quick look at the command line options. So I mentioned that we have parity between what is possible in the UI and in the command line tools. We have in the Hop directory that I started my GUI from, we have a number of scripts. So we have hopconf to manage our configuration, the GUI, the server, and there's a translator as well, which is a GUI tool to translate all of the messages in the Hop UI into your own language. So I'm pretty sure that the support for Polish is not 100% complete. You could use the translator to work on translations and translate Hop into your own native language.
Yep. Sorry, Bart, for interrupting. If you have more things to show on the Bash, could you zoom, because
yeah, of course, yeah.
Small window, and it's a little bit, I would say, can read it. Or
yeah, sorry.
Make it bigger or just zoom there. Yeah. Oh, now it's much more better.
Is that okay? Well, and I won't. I'll show a quick example, but I won't bother you with 20 minutes of command line lingo. But the Hop run is a pretty useful one. Well, what you do in Hop run is specify what is available as metadata in the UI as well. So you have the environment, the file that you want to run, the project, the parameters that you want to pass to your pipeline or workflow, the run config that you want to use, and so on. So if we use one of the examples that I just showed is right. So we have the samples project and generate a JSON file. And what you see here is that this enables the samples project, and the information that you get in the output here is similar to what we saw in the execution results. So in this in the panel here. Yeah, so this can be added to your cron, or other scheduling tools can be used in containers. So that's done, and yeah, still running. This is a pretty large CSV file that we're processing. Same goes for if you run things on Spark, you don't want to you do that for well, megabyte CSV file, you need a significant amount of data before it's worth it. But once the amount of data is more than what you can manage on your local machine, then, well, definitely in big data projects, this is really powerful. We're almost there on the last transform. In the meantime, if you have any questions.
Yeah, we have 3 questions actually.
Okay.
What's the difference between Hop and Airflow?
Oh,
This is a big one.
yeah, well, yes and no. Airflow is, I'm not an Airflow expert, but what you do in Airflow is you specify a number of tasks where what Airflow does is it manages the tasks themselves. It doesn't really handle the tasks. Well, that is not what Airflow does. And of course, there are parallels between what a workflow in Hop does. So what you do here has some overlap with what Airflow does, but the main difference is in what you do in the pipelines. There's no equivalent to pipelines in Airflow that I know of. So I think it's not a matter of how are they different or how would they compete. I think there is an overlap where actually we've been thinking about it, and probably will do at some point in the future, where a workflow could run on Airflow. So this would translate pretty nicely into a DAG, and in a lot of cases these things get a lot more complex. So, for example, you have a simple evaluation where you would do an action. So let's say this is our normal flow. If everything goes well, we continue left to right, continue executing pipelines. If we have an error, then we'll evaluate what the nature of the error is, maybe send, maybe write something to log, execute an error handling pipeline, etc. And you'll end up with pretty complex workflows, not necessarily, well, complex, but pretty verbose workflows. And parts of those could definitely be translated into an Airflow DAG. So there definitely is integration between Airflow, or what Airflow does, and what a Hop workflow does. Not so much as far as pipelines are concerned. Does that answer the question? Or?
For me, yes. The next one is, does it provide API for execution the same actions programmatically?
Well, yes, there are a couple of ways. I don't have an example, but we have a REST API where you can use REST calls to execute a pipeline or a workflow on the Hop server. And actually, there is a web service metadata item where you can specify a pipeline that you can call as a web service. I can point you to the documentation on that. It's not something I can demo in 10 seconds, but we have web services that are an integrated part of of the system. And on the server, you can run pipelines and workflows through REST calls, and there is an SDK.
Okay, and does Hop provide data transformation and cleansing actions?
Yeah, well, everything we do in the pipelines more or less are ways of transforming your data. So I've shown a couple of simple ones here that add data or do a calculation. We also have, for example, a merge join where you do more or less a join as in SQL. So this takes a first and second are these streams that you add to your merge join, and then you can specify inner, left, right, or full outer join. So very similar to SQL. There are a number of lookups. So we have a dimension lookup update to do slowly changing dimension lookup and updates from the data warehouse world. You can do a database join where you combine the information in your stream with information that you get from a database query. There are default database lookup, a stream lookup where you do a lookup to an in-memory data set. So there are quite a number of ways to enrich your data. And there is a data validator that is in the process of being ported, where well, that data validator transform allows you to create a number of business rules. So for example, double check that the value of a string field is has a maximum length of X, does not contain values X, Y, Z, or ABC, that a date is within a given range. So there are a number of actions that you can take to definitely to enrich data, and to a certain extent to do data quality. And even though Hop is not a data quality platform, you can build your own data quality solutions as well. And we have these. There is a pipeline probe, which is a metadata type that allows you to specify another pipeline, and while running one pipeline, the pipeline that you specify here will receive the data and can be used to do data profiling, lineage, etc. So there are quite a number of options to definitely to enrich, transform, and do data quality checks.
Okay, nice. And the last one, I think, how does it store metadata state?
State as in what is the definition of these files? Is that the question?
Right, yeah, exactly this one. So all metadata regarding pipelines.
Yeah, well, same is true for workflows and pipelines. Both are stored in XML at the moment. So, well, these are the properties of this pipeline. And let me grab my editor. So if you open that file definition, it's just a plain XML file, and it's XML for now, because that is the format that was used by Pentaho, by Kettle, and we kept it for now, but we have discussed and we have thought about making that pluggable as well. So instead of just having XML, you would also have the possibility to store workflows and pipelines in JSON, YAML, whatever. And except, well, everything else, all of the metadata here is defined as JSON. So let me check if I can bring that up quickly. Well, I can bring that up quickly, but so this is my project folder. Let's see if I can zoom in here as well. So in this metadata folder, you see this this corresponds to what we have in the metadata perspective. So you have the data sets, the web service, the run configurations, pipeline log, pipeline probe, and everything we have here. So for example, this run configuration is stored as JSON files. So the where is my code? So the run configuration is a pretty simple JSON file, and so are the project environment definitions. So it's at the moment it's all a combination of JSON for everything but the pipelines and workflows.
Okay, and how about state machine, like current state for current workflow, history? Like, is it also stored as files?
Yes, and that is, yeah, it's JSON files as well. So there is an audit folder where for every project there we keep the state of the UI, the latest pipeline run configurations, the latest actions on pipelines, and the same for configuration. So we have a config file with metadata for, I think this is rather old. This is from my previous settings, but everything, all of your environment settings basically are specified as configuration files as well.
Okay, thank you.
And that actually, well, the project, for example, the project definition is something you'll store in your Git repository as well, together with your project files. And then the environment configurations would not be included because those might contain well, environment specific or even sensitive information. But that allows you to have a pretty good split of project specific and environment specific configuration.
Okay, so one more question.
Sure.
Can this tool be successfully used as a replacement for Apache NIFI, but adds even more as for data processing?
Yeah, yeah. I think the use cases that we as Hop do are similar to what NiFi does. So it could be a replacement. And what we have here is there's an import from Kettle PDI. What this does is it imports the code that you have in Pentaho data integration, jobs and transformations to Hop workflows and pipelines. And we have been discussing the possibility of importing metadata from other tools as well, and NiFi could be an option. So there is well, in the case of NiFi, there is a lot more overlap than in the case of Airflow that we just discussed. So yeah, there definitely is quite a bit of overlap with what NiFi does. I think NiFi is different in the sense that they started as a tool in the Hadoop ecosystem, and we as Hop are a completely separate platform, independent. We integrate with just about any architecture, but we don't have any dependency on any component.
Okay, so I think we can move on.
Okay. Well, I think I just checked the data flow job finished here, so that's I can as a last one, I can run this on Spark as well. And basically this is just the same. So Spark started a runner here to process that same transformation that we had a look at a minute ago, but without changing anything in the pipeline. We can switch between a local hop engine, a remote engine, remote hop engine, so a hop that runs on a remote server, or through Spark on through Beam on Spark, as we do in this case, or on Apache Flink. And this takes, I think it takes about a minute to process. But of course, well, in the typical big data, large volume projects where you would use this well, limited extra startup time is neglectable. And well, once the pipeline has executed successfully, this UI is shut down again. But this is yeah. This was Spark. So that's basically everything that I wanted to show in a nutshell. I don't know, any more questions, any other things that you'd like to see in more detail, let me know.
I don't see any questions, but I think I may ask about connecting to databases. Java has some like JDBC, etc. So can Hop easily connect to any database and get data?
Yeah, absolutely. Yeah, that's and actually I skipped that because it's let's assume that is a covered territory. Databases are a pluggable metadata item as well. So in the metadata perspective, we have the relational database connection, and well, we have ClickHouse, DB2, BigQuery, Snowflake, Vertica. So just about any database is supported. So for example, let's see, I have a local Postgres. Let's just use Postgres tests. Yeah. Okay, so connection was successful. And now if I go back to my, let's say, new pipeline, What I can do here is use a table input to read data, but yeah, I'll use this table input in a minute. But just for table, we have a table input, a transform that reads table names, checks if tables exist, do delete, write to, so it's just an insert, update of a table. We have an insert update as well. It doesn't match the table, but there's so for update we have insert update and standard update, so synchronize after merge is another one. And this is just a query input, so I could just select a table in, well, let's say in the information schema. There's some basic operations, so preview the first 100 rows, for example. I can add this table with or without the column names, do preview, and so on. So yeah, databases are pretty well covered. That has been in Pentaho data integration since the very beginning, and that's just something we inherited. And let's see, so we have table output to write. I think we discussed a couple of the database operations for lookups as well. So there's execute a database procedure, do a database join, do a database lookup. Dynamic SQL row is where you generate a SQL statement and execute that as part of your stream. Check if columns exist. And in the workflows, there are a couple of actions that you can do on databases as well. So check if columns exist, evaluate number of rows, truncate, a couple of bulk loaders that we have on the pipeline side as well. And well, the bulk loaders are really useful if you have large volumes of data to insert. Bulk loading is a lot faster than batch inserting data. So yeah, databases are covered, I would say. If there's anything specific that you think about now, let me know and we can have a look in more detail. But databases are not something that you'll run into into limitations with, I would say.
Yeah, it's one of the most common thing in data workflows. So
yeah, and well, the origins of Pentaho data integration were in the classical ETL, so in building data warehouses, and data warehouses are databases. So integration with relational databases is crucial. There is quite a bit of support for NoSQL databases as well. So we have MongoDB input-output. I don't have the plugins installed in this version, but there is a really good integration with Neo4j, Kafka, you name it, but relational is definitely covered.
okay, I don't see any questions left, I think. So we can move on if we have anything left.
Okay. Anything else that you would like to see. More or less went through the list of things that I wanted to show. But if there's anything else that you would like to see or would like to to have more information about, let me know.
I don't see anything if someone has to. Okay, so do we have anything in the schedule?
Well, I can continue to show other features, more transforms. But what what I had on my list is covered at the moment.
Okay, so I don't see any questions. Let's give attendees 1 more minute if anyone has anything. And I think we'll be able to end for today, I think.
Okay.